Okay guys, so we'll be continuing on seeing examples on second order reaction and third order reaction. So let's get started. So for second order reaction, we can have an example like CS3 C double bond O C2H5 aqueous reacting with NaOH aqueous forming CS3 C double bond O Na aqueous plus C2H5 OH aqueous. Okay, so this was an example of second order reaction. So let's now see an example for third order reaction. So for third order reaction, we can see an example like we can have 2 moles of NO reacting with oxygen forming 2 moles of NO2G, and similarly 2 moles of NOG reacting with Br2 forming 2 moles of NOBr gaseous form. We can also have some examples of fractional order reactions. By the way, all these order of reaction were determined experimentally. So fractional order reaction, example can be carbon monoxide reacting with oxygen forming COCl2. Rate for this reaction can be written as K times CO and Cl2. Okay, by the way, this is not O2, this is Cl2. Cl2 raised to the power 3 by 2. I am again writing a note here that rate of reaction is an experimentally determined quantity. Rate of reaction, or rather order of reaction, is an experimentally determined quantity. Determined quantity. Okay. So the next point is the number of reacting species which can be either atoms, molecules, or ions that are participating in an elementary reaction or elementary step is called molecularity of the reaction. Next we have that number of reacting species. Reacting species can be atoms, molecules, or ions participating in an elementary reaction. Is called molecularity of the reaction. By the way, reaction or elementary step as well is called molecularity of the reaction. Okay, and a complex reaction has 2 or more than 2 elementary steps, and every elementary step has its own molecularity. And molecularity has no meaning for a complex reaction because molecularity of the reaction may be 1, 2, or 3 depending upon the elementary steps taking place in the overall complex reaction. And molecularity of the reaction cannot be ever be 0, fractional, or negative. So let me write this point down as well. A complex reaction has 2 or more than 2 elementary steps and every elementary step has its own molecularity. Thirdly, molecularity has no meaning for a complex reaction. And molecularity of a reaction may be 1, 2 or 3 and so on. But it cannot be 0, fractional or negative. Okay. Next, molecularity of the reaction which is greater than 3 is not observed. That's why we are stopping at 3. Next point is molecularity of a reaction greater than 3 is not observed. Next, we'll be seeing a unimolecular elementary reaction. So it is a first order reaction because the molecularity of a unimolecular elementary reaction would be the same as the order of the reaction. The molecularity of a unimolecular elementary reaction would be 1, hence it would be a first order reaction. And bimolecular elementary reaction is a second order reaction. From the same we can write that bimolecular elementary reactions is an example of second order reaction, or it is a second order reaction. Similarly, for trimolecular reaction we can write that its order would be 3. So let me write it down in points that for elementary reactions, molecularity of the reaction is equal to the order of reaction, which is equal to the sum of stoichiometric coefficients of reactants. We can write that molecularity of the reaction is equal to the order of reaction, which is equal to the sum of stoichiometric coefficients of reactants. Sum of stoichiometric coefficients of reactants. So now let's take an example of a complex reaction. So in a complex reaction, if we write that suppose 3a plus b gives c plus d as the final products, it is being divided into some elementary steps. In the first step we get AB gets converted into I. So this is, let's say, a fast step, and molecularity of this reaction would be nothing but 1 plus 1, which would be 2, as two molecules, atoms or ions are combining together to form a product. So molecularity of the first step or the elementary step would be 2. Next what happens is The remaining A again reacts with I to form X plus Y, and this is a slow process, and the molecularity of this reaction again would be 2, because two atoms, ions or molecules are combining together to form products in the second elementary step. These are all the elementary steps. And the third step is the remaining I now reacts with X plus Y to form C plus D, and this is very slow, let's say, and the molecularity of this step would be 3. And overall what is happening is 3A, 1, 2 and 3 plus this I is there in both the reactant and the product side, so they cancel out each other in the final equation. Similarly for this X and Y, so we are only left with 3A plus B combining together to form C plus D. So this is the overall step, or the overall complex reaction consisting of 3 elementary steps, in which the molecularity of each step was 2, 2 and 3 respectively. So with this we come to the end of this lecture. In the next lecture we'll be seeing redetermining step. So we'll meet in the next lecture. Till then, good luck and goodbye.